Okay. So today what we're going to do is we are going to talk about, so on Friday we talked about graphing these systems of linear inequalities. We graph them in slope-intercept form and we graph them in standard form. You guys had the solid, the dashed lines, where to shade. We had those different regions. We're still kind of practicing with that. Remember, you had an assignment on Friday that is due tomorrow. So if you still need to finish that, you should be working on that today as well. Your assignment today is short. Basically, today what I want to talk about, we were graphing and shading, which is the big part of these systems of inequalities. But what we really didn't talk about is what does a solution really mean? What does it look like in these systems? So if you can pull out your 2-6 notes, we had done this, the vocabulary in example 1 on Friday. And sorry, it's not filled in here, but remember example 1A was in slope-intercept form. Example 1B was in that standard form, which is a little trickier. So I told you guys you could put it in slope-intercept form if you want to, but I also showed you how to do it in standard form. And then we looked at the books example, which was graphing like 3 different equations in a system, which looks weird, but is doable. Today, what I want to look at is just what these solutions of linear inequalities mean. Both what they mean algebraically, so when you plug them in and calculate out some inequalities, and what they mean on the graph. So I actually want to do example 2B first. This is going to be, you have 4 problems today on your homework assignment. 2 of them look like 2B. And I want to test what these look like algebraically to start. So we have our system here. This y is greater than 4x minus 3, and y is greater than or equal to negative 2x plus 3. And this is going to be a bit of writing. We're going to go through and plug in each point to see if it makes the system true or false. And if it makes it true, that means it's a solution. And if it makes it false, that means it's not a solution. So I'm going to start by testing 1, 4. Remember, this is your x, this is your y. I'll plug it into this equation first. I'm going to plug in the y and the x. I'm going to color code here, so if you have colors, that might be helpful. So my y would be 4 is greater than 4 times 1, my x value, minus 3. 4 times 1 is just 4 minus 3 would be 4 is greater than 1. Once you have this with like a number, greater than or less than or whatever, another number, you know you can actually test this, is 4 greater than 1. That's true. So it is true for this equation, but we need to test it for the whole system. So now I'm going to test it in this other equation. So I'm still plugging in 1 and 4. So I'd have 4 is greater than or equal to negative 2 times 1 plus 3. Negative 2 times 1 is negative 2. Negative 2 plus 3 is the same as 3 minus 2, which would be 1. So 4 is greater than or equal to 1. That is also true. Since these are both true, this is a solution of that system. I'll do the next one in green. So now I'm going to test this point, where that's my x, that's my y. Let me scoot this over. So now I'm going to plug in to my first equation, negative 3, my new y, is greater than 4 times 0 minus 3. Well, this is saying negative 3 is 4 times 0 is just 0, and 0 minus 3 is negative 3. Negative 3 is greater than negative 3. Here's where we have to be careful, and this is why it's so important, the difference between our dotted line and our solid line. Remember, when it's just greater than with no equal sign underneath, that means this is a dotted line. And the reason for that is because negative 3 is not strictly greater than negative 3. If this was equal to, this would be true. But since it's not, this is just not true. And if you run across one equation that makes the system true, that means this point is not a solution to the system, and you can just stop. So again, it's really important to pay attention to like if it's greater than or equal to. Testing this point next. So now I'm going to test in blue 2, negative 1. So this will be my new x. This will be my new y. Test it here. So plugging into this first equation, -1 is greater than 4 times 2 minus 3. So -1 is greater than 4 times 2 is 8, minus 3 is 5. Again, I'm kind of like at a full stop here. -1 is not greater than 5. Since this is not true, and sorry, I should have put green X there. Also not true here. That means that this is not a solution. Sorry, that looks like I'm saying X there, but I'm just saying that's not true. Okay, next one I'll do in purple. -1, 1. So now this is my new X, this is my new Y. Plugging into the first equation, 1 is greater than 4 times -1 minus 3. What that says is -4 minus 3 is -7. So 1 is greater than -7. That is true. Think about your number line. What's more to the left? What's more to the right? So this is true. So it's true for the purple one, meaning I have to test the second equation now. So in my second equation, I have 1 is greater than or equal to -2 times -1 plus 3. 1 is greater than or equal to, let's see here, -2 times -1 would be +2, plus 3 is 5. Ooh, that's not true. So since one of them is not true, that is not a solution of this system. Okay, before I move on, are there any questions about this? Are we all good? I want to kind of try doing a poll here. Let's see if I post a poll question. Any questions on example 2B? I'm going to start a poll. Yes. No, this way you guys don't have to talk, but you can still let me know if there's any questions. So I'm going to hit launch here. You guys should have a poll. Quickly answer the poll. See if there's any questions. Say yes. No, I have 2 votes for no, 4 votes for no. $11 votes for no, so at least 11 of you are awake. That's good. 12 votes. Okay. So if you do have any questions on this one, I'll come back to that. Make sure you answer that poll for me. Let's look at example 2A now while we're looking at that. So example 2A now, this is the simpler one. These ones I don't really need work for. This is more for you kind of to talk yourself through. So this is where you can actually plot these points on the graph and decide whether or not they're solutions. So I'm going to start, again, I'm going to color code the first one will be red. 1, 1. If I plot 1, 1 on this graph, that point is right here. That is not in our shaded area. So that means this is not a solution. So our first thing that can happen here is not in shaded area, which means not a solution. Okay, that's the first case. Second case scenario, -2, 1. So if I go over x -2, y is 1. That is in our shaded area. So second is in shaded area. That means it is a solution. That's why it is important where we're shading. So 2, 1 is a solution. I'm going to circle it. On Go Formative, you'll select it. Now let's test -3, 3. So if I go over to x is -3, y is 3. This is on the dotted line. So this is why it's really important that we pay attention to whether or not our lines are dotted or solid. Remember, the dotted line means that this is less than or greater than, but there's no equal to. And that looks like what happened here in this example 2B, the green one that we tested, right? Where it was -3 is greater than -3. And we said that's not true because it's not equal to. So that's why if it's on the dotted line, our third case that can happen, so is on dotted line, so it is not a solution. So that means this is not a solution. So I guess I should have crossed off this one too, huh? The last thing that we can see happening in our graph is this case here where it's 1, 0. When it's 1, 0, so I go over 1, up 0. Notice that that's exactly on the solid line here. So solid line is where in this case it would have been less than or equal to. And since it's got that equal to, that means it is a solution. So is on solid line. That means it is a solution. So those are kind of the 4 cases that you can see. I don't need work for those ones. Let me do another little poll here. I had no questions on that one. Let me do any questions on example 2A. I keep thinking this laptop is a touch screen and it's not. This poll. Are there any questions on example 2A? There's another poll for you to answer. Okay, I don't have any questions on example 2B. So, and feel free to ask me questions once we get to the assignment here. But in our assignment, oops, let me remember where to go here. So if you look under classwork, it's 2-6 day 2 on Go Formative, whatever we're calling this app nowadays. So our settings for this formative, this is like a multiple select one. So it's not like multiple choice where you only select one. You can select multiple things. I do not have partial credit turned on because I don't want you just to click around until you get your like green buttons. So it's all or nothing. So you have to have it completely correct for it to show up green. The first 2 problems are like example 2A where it's just a graphing one. I do not need work for these. Okay, those fall into those 4 cases that we saw. Example 3 and 4 are the algebraic ones. These ones I do need work for. And again, this is where you're just going to select some and you'll see if you get it right or wrong based on what you selected. Then you can select multiple. So I do need work for 3 and 4. I do not need work for 1 and 2. I am going to mute myself, but I am here. So if you have any questions, let me know. We have until, officially we have until 9:05, but remember I'll probably let you go at 9 o'clock. But I'm going to take attendance real quick and we'll go from there. So muting myself, you guys can get started on this, but I'm here if you have any questions.